Well, I wanted to welcome everybody today to the Cybersecurity as Big Data Science Interactive Workshop. It's great to see so many new faces. This was a meeting that we have been planning for about a couple of months now to really try and get some interactive discussions between people to foster new ideas in data science and in cyber infrastructure. I'm Niall Gaffney. I'm the Director for Data Computing here at the Texas Advanced Computing Center. But I'm here in my role as chair for the Cyber Infrastructure and Data Sharing Working Group for the 4 Big Data Hubs. And today we're going to have an interesting interactive discussion here, which I think really touches on many of the key pieces of many challenges towards a lot of big data problems today as far as AI and machine learning goes, and that is cybersecurity. And not in the sense of compliance, but more so in the sense of detection and reaction to events. A lot of these are shared with other areas. I mean, it's a widely distributed data field. So this is very similar to things like smart agriculture or even large telescope surveys. It has a lot of security concerns. So it has some similarities to things that are going on in medical professions. It's about remote detections with poorly labeled data, which is really a challenge for everyone. And lastly, it's about really detecting things that really aren't known per se in advance, because of course, what we're trying to find is the new things that are going on in the realm of cybersecurity and react to those. So with that, I think we have an interesting mix of both common data science problems and a unique problem set here. And I'm hoping today we can have that discussion where we bring together ideas and maybe start something new around this topic here. We're going to have an hour-and-a-half panel here. There are going to be polls and other things to sort of keep us going and keep us on track with what people are interested in. But then following this, as the next cyber infrastructure Big Data's working group meeting on Friday, May 7th at 3 p.m. Eastern, we'll be hosting another session to just sort of have more discussions around what has occurred to people or how things are working after all this sinks in, and we've had a chance to think about what we've learned and talked about today. So with that, I would like to hand this over to Jay, who's going to start us off with an introduction to what the workshop is going to be about. So Jay Yang, please take it away.
Thank you, Niall. Thank you everyone for coming over here. I'm very excited to have this interactive workshop. That's the key word. One of you already asked about whether the slide be shared. Yes, the limited slide will be shared, but mostly we'll be hearing from you, our community. So this workshop will be recorded. And so if you do have any concerns, then please let us know. We'll work out a way so that this recording will not be shared to the public, but to share with just the participants. So why we are here? Why are we here? We're here because there has been a lot of cybersecurity practitioners. They are really overwhelmed by a lot of data, right? The shared common properties with other big data science problems. And there's a lot of use cases. You'll hear quite a lot from the panelists today. At the same time, they're really interested in learning and adopting the AI ML data science tools, but not necessarily sure exactly what's the best way to begin. Meanwhile, the researchers working on this area, like myself, has really limited and mostly unrealistic data to work with. We also face a lot of challenges to bring our advances to real practices, right, in operation. And we also recognize that there are a lot of data science techniques out there, not necessarily for cybersecurity, they could still be beneficial but could be overlooked as well. So we really wanted to bring the community together to talk about the use cases, right? The challenges, technical and non-technical challenges, the plausible solutions, best practices, right? Not just technical solutions, but best practice to get it done, right? And how do we engage, training, and educate people in this area? So I wanted to have this discussion with you. So it's very interesting. We have 140 registrations as of maybe yesterday. And there's a lot of come from a variety of different interests, background and areas and so on and so forth. And we have people coming from 11 countries. Very proud of this broad region. Thank you, Florence and Northeast Big Data Hub behind the scene to get this working. Helen, Tia, all of those. So we really want to use a variety of ways to interact with you today, right? So one of them is the poll. Helen, if you can launch a poll, so that we can know that why you are here, what you want to learn. More importantly, that we want you to use the Google Doc. We share the link in the Zoom chat. And in the Google Doc, that you will see, you have a few different sections. You can put your comments in, just put your bullet points. Don't be afraid, don't be shy, put them in. You can use the Zoom chat, and if you feel more comfortable with that, and we'll try to copy and paste those Zoom chats into the online Google Doc. And you can also raise your virtual hand. If you don't know how to do that, I guess that we can provide instruction in the chat for you, the virtual hand, and we'll track them as much as we can. You know, if we do have 140 people here, it's very difficult to track. We'll do our best. And then we'll call you to speak. So again, this workshop will be recorded. If you don't feel comfortable speaking and being recorded, you can definitely use the chat or the Google Doc, right? And so what we're going to do today is we invited a few very good panelists. I'm very proud to have these panelists all together to share their thoughts with you. Sagar from Indiana University, Kathy with the Pittsburgh Supercomputing Center, Amarnath is with the San Diego Supercomputing Center from UC San Diego, and Jelena from Information Science Institute from USC. And of course, you. So I would really want to stress that this workshop, this next 1 hour and 20 minutes, is not just about the panelists presenting. You will see very, very few slides, probably no more than 10, because we really want to hear from you, your thoughts, right? Through the Google Doc, raise the virtual hand, the chat, any ways you can to share with you your thoughts, right? Whether it's your concerns, your challenges, suggestions you have, we want to listen. So the topical areas, as I said earlier, will be use cases, challenges, again, technical and non-technical, solutions, best practices, suggestions, and we'll talk about how to potentially engage further, training, education, and we'll wrap up with the next step we can do from this workshop. Now, I already mentioned about the working group monthly meetings, all right? So we'll begin by hearing briefly from the panelists for their thoughts on the use case and challenges. Sagar is going to present very briefly, and then Kathy, Amarnath, and Jelena will briefly talk about their thoughts as well. Right? I'm going to unshare my screen and have Sagar take it away. Sagar?
Thank you, Jay. So let me share my screen here. So can everybody see my screen?
Yes.
Okay, perfect. Yeah. So thank you so much, Jay, and also thank you, Florence and Northeast Big Data Hub, for the opportunity to have this workshop and this interactive workshop, and to really get some good ideas flowing in terms of this emerging area. So I only have a few slides to kind of set the stage for the other panelists here. I'm not going to speak for too long, at 5 minutes maximum, but I really want to kind of just set the stage as to why cybersecurity as a big data science, some of the challenges and the opportunities. So as Jay mentioned, I'm at Indiana University. I'm an assistant professor in the Kelley School of Business. I've been here for about 8 months now, but I've been working in the space of big data science for cybersecurity for about the last 6 or 7 years since the start of my doctorate. So I think the first question is why the focus on cybersecurity? We've heard data science in many other contexts as well, but why cybersecurity? And really, I'm not going to belabor the fact too much that cyber attacks really cost the global economy a tremendous amount of money on an annual basis. And really, no single sector is immune from these types of attacks. It really affects government, industry, academia, and so on. And I know that we have coverage from about 11 different countries here today, but within the US, it's really been labeled as one of the national strategic priorities. Now, for cybersecurity and data science, some of the common challenges that many cybersecurity practitioners and academics face is data overload, prioritizing the appropriate indicators, ever-evolving data sources, and so on. So even though the areas of data science and cybersecurity have historically been a little bit siloed, they do have they have the potential to have great relationship with each other. They're not just buzzwords. And really, if I were to summarize it down, what is the role of data science in cybersecurity? It's twofold. It can help automate many procedures that security analysts or security professionals do manually on a day-to-day basis, but it can also help identify patterns within large data sets that were not necessarily available through manual analysis or through other cybersecurity mechanisms. I think the real question that comes up in terms of doing data science for cybersecurity is that what is the data that is relevant within cybersecurity? And there's really kind of two broad areas that of data that's accessible within the cybersecurity context. And on the sign up page for the Big Data Hub, or for this particular workshop on the Northeast Big Data Hub, there was an editorial link at the bottom that summarizes this a little bit further, but really, there are two major categories of data sources within that can be used for cybersecurity applications. One is internal and the other one is external. And the key delineation is internal is the type of data that's within an organization that any organization would have access to. And external is outside in cyberspace itself. So within internal data sources, we have things like workstations, data storage, networking devices, network fingerprint data, NetFlow data, and so on and so forth. And some of their key characteristics is that they're very close to the critical assets of many organizations. The data is primarily machine generated, i.e. there's devices that are generating these data, and they're generated with a tremendous amount of velocity. They can provide a great insight into some of the existing threats and past attacks as well, but the heterogeneity and the velocity of the data can be quite substantial here. And then there's external data, so data sources that are external to an organization. So this could be IoT search engines, dark web related data, carding shops, paste sites, threat feeds, and so on. It gives a great perspective of threats that are external to an organization. This data is primarily generated by humans, also has a high velocity, and also has many different non-standard formats with significant noise and variation. So there's a tremendous amount of data to be had in this space, but how to actually manage it effectively and gain some interesting insights out of it still is yet to be determined. Thus far, there are really four major themes of data science or cybersecurity that have emerged. One is cyber threat intelligence, disinformation, computational propaganda, security operations centers, and adversarial machine learning. But as you'll hear from some of the panelists today, some of the key limitations within the space is that there's often very siloed resources. There's often a lack of publicly accessible and diverse data sets that are realistic, as well as labeled or balanced. And then things such as model sharing also remains a challenge as well. So this is the last point that I'll bring up here, is that there are a lot of emerging opportunities in this space for data science in this area that can be done from a multidisciplinary perspective. We're really looking forward to hearing from you from these perspectives. There's all the way from emerging applications and data to different types of AI-based methodologies, such as multi-view learning and multimodal analysis, to the role of decision-making within this particular context. So we're having more automated predictions and resiliency and those types of topics. But we'll delve into a little bit more of this as we proceed forward. So with that, I'll go ahead and stop sharing my slides, and then I think Kathy's up next.
Thanks, Sagar. My name's Kathy Benninger. I would like to thank Jay for inviting me to participate today. I am the manager of networking research at the Pittsburgh Supercomputing Center based at Carnegie Mellon. I've been at POC for over 30 years. I've worked in a range of cyber infrastructure projects, earlier years, compute storage and video systems. But most recently, I've been focusing on networking, network performance and emerging network technologies. So I kind of come to it from that perspective. Since 2019, I joined Trusted CI, so I've been able to start building my skills and experience in the area of cybersecurity. With regard to use cases and challenges for application of big data and AI, there seems to be a strong opportunity within the area that Trusted CI works with, of the NSF's large facilities. One of my roles with Trusted CI is coordinating the NSF large facilities security team. These team members are representatives from each of NSF's major facilities who are responsible for cybersecurity at their respective sites. For folks who aren't necessarily familiar with the major facilities, those are the NSF projects that are funded at $100 million and above. So they're things such as the observatories, telescopes, LIGO, and Arctic programs. And Trusted CI works with them and facilitates their collaboration on cybersecurity related issues. So just kind of thinking about that from my experience with the major facilities and some of their areas of interest and concerns, kind of an obvious use case there is the fundamental protection for these unique resources and scientific instruments at the facilities, to the extent that threat detection or attack and unauthorized access detection could be done of these potentially attractive targets would be a large win for the organizations. There's also challenges that these organizations face, that any type of security such as this has to be done in the context of trustworthy open science, while at the same time supporting large distributed kind of varied user communities. Also, the security needs to be done, but maintaining secure and efficient access to the data sets that are collected at the facilities. The part of the challenge here also, the major facilities are attractive targets, and the folks who work in the cybersecurity roles within the sites are sometimes there's a separation between what they're doing and some of the data science applications. So there's some area of work that can be done in that area. So those are just some of the issues that large facilities are facing.
Thank you, Kathy, for the insights. Next, we can hear from Amarnath.
Yeah, so I know that there was a statement about not having slides. It'll sometimes easier to show people. So let me share, and I'm sorry, Jelena, I think there is a, can you see my screen? Can everybody see my screen? Yes, okay. So let me first talk about the problem. So we at San Diego Supercomputer Center, we have a lab where we look at how to gather data from various sources and how to analyze them together. So there was one question from Andreas that said, what kind of data model should you use? Should it be a document database, graph database, etc., right? So let me speak to that with respect to our work. So here are two cases that we talk about. So there are standards, people have said, okay, there is an attack. Can we characterize the attack? And there are weaknesses of known software systems, like documented weaknesses. So if you look at that, NIST and other people, MITRE Corporation, have created these standards. So there is a common weakness enumerator, so CWE. There is a National Vulnerability Database, which essentially tries to document things. And the goal is when you see a new incident report coming, not from the machine like Sagar said, but somebody puts it in. Okay, here is what's happening with my system. Looks like it's a security problem. Can I have an agent?
Do you want to advance the slides? We only see.
No, I'm not going away from this slide.
Oh, okay.
I'll tell you when. So if I advance the slide, I'll tell you. I'm essentially trying to sort of give the setting for this without showing too many slides. The question is the data science problem is this. I have an incident report. I have a slew of them, and they keep coming. Can I take that and use some technique by which I can figure out how severe this is? Do I know exactly what known weakness it's pointing to? In doing that, can I utilize the existing knowledge that these National Vulnerability Database and other people have gathered. So can I really classify? And then if I understand the progression of what is happening with me, can I identify the attack pattern? So this problem of trying to get sort of a systematic understanding of the incident reports that keep flying by, how far can we automate it? So this is one of the problems. And the tack we are trying to take is how can we use NLP? I'm not going to dwell on this slide too much, but this is one class of problems. And what we can use knowledge graphs and ontologies and NLP to characterize the problem. The second problem comes from here. So this is social media. And this business has been called threat intelligence. It has also been called risk intelligence. Here are two tweets that we gather. We gather like 3.5 million tweets per day on various things. So this was happening on the 1st of January. And you would see that there are some agitated people talking about fighting, if something goes wrong in politics. Now the question is this risky or is this not risky? Is there a chance that it would lead to physical violence? Obviously, I'm showing you just two tweets. We have hundreds of thousands of tweets like this. And the question, therefore, is what can we do as data science thinkers to take this and do some kind of risk intelligence analysis? What we have figured out is now the issue about data models and so forth, there is no one thing that you can do. We have some of the data in relational tables. We have some of the data in networks. We have some of the data in time series analysis. And indeed, we have some of the data in text analysis. And we try to combine this heterogeneous analytics to see if we can figure out what's going on. One of the things we see is we actually see very interesting patterns emerging from who is talking about what to whom. And we see these clusters and how people are talking across communities.
I think Amarnath froze. Can you guys still hear me?
Yeah, Amarnath, maybe you could try turning off your video just so that your audio comes through clearly. Because you're breaking up. There's probably something Meta to say about the robotic sound of his voice and breaking up in our topic.
So meanwhile, while we are waiting, Jelena will be the next. At the same time, the audience, feel free to put in your question. We already see some questions in the Google Doc chat as well. Amarnath, are you back?
I am.
Okay.
Sorry, I'll take just one more. I have to go to challenges. So some of the challenges we face is first, there isn't adequate data to create analytical method models or create machine learning models. And then everybody else will tell you that there is a problem with training. I think one of the things that needs to waiting for training data, we need to create platforms by which we can develop training data for specific problems. That doesn't seem to be happening a lot. Mm. Also, some of the inferences are not interpretable. In order to do that, we need to figure out what kind of context we should use to get a better interpretable data out of what we are seeing from the regular massive data sets. So I'll stop here. If you have any questions, please feel to ask.
Thank you. There are some questions already for you, Amarnath, on the Google Doc. You can take a look. Next, we have Jelena.
I will come back to that as soon as I can.
Okay, hi everyone. I'm Jelena Mirkovic. I'm research associate professor at USC, and I work on cybersecurity, on detection of network attacks. So for a while, I came to this problem of cybersecurity and big data from the research direction, looking for data sets and how can we understand the data sets and develop, use them to test our defenses. And I primarily worked with two types of data. One type is networking data, looking at the network headers. And then the other type is human-based data, mostly passwords, how people develop passwords and how they choose them, how they reuse them, and so on. And both of these types of data are very sensitive. They are hard to share. So many research papers are published that, with great results, but the data that is being used is private data. And no one can repeat the results. No one can, compare some technique that they developed with the technique that was published, because we don't have the same data that is equally large and rich. So there's this problem of data sharing that is pervasive when you talk about cybersecurity data. And some issues that arise around that are privacy issues, but also reputation issues. So even if you anonymize everything, but just, the company X publishing that they've been attacked that many times in a year might raise concerns. So that's one issue, how to share the data. And then the other issue that I'm very interested in is how to label data, because as you heard from other panelists, the ground truth is very elusive in this realm. Usually what people do is they use commercial products to label data. For example, if you're researching malware, you might use VirusTotal to label it and say, this is malware, this is benign. But even the commercial technologies are just, technologies that are trying to do their best to label this data. They are not 100% correct. And so the question then arises, if you develop some technique that is, say, better than commercial in some aspects, how can you prove that when you don't have ground truth, when you don't have the labeled data? And so one approach that I'm working on with my colleagues is looking how to devise these probabilistic labels that multiple researchers could assign to the same data set, and then other researchers could work with these labels, and we could have this probabilistic ground truth.
Thank you, Jelena. I think this is great insight on that. There's a lot of angles on that. So I just posted in the chat box where you can put things into the Google Doc, you can raise hands. Please feel free to raise hands. We'll have people to track that and then invite you to speak up. Meanwhile, I want to share with you, so the earlier poll that we did, most of you were wanting to learn more about what kind of approaches, data science approaches can help solve cybersecurity problems. And many of you want to know cybersecurity problems that could benefit, so it's bi-directional. We're really glad to see that. So right now we are in these topics of use cases and challenges. We really want to hear from you. Several of you are typing as we speak. I'm actually watching online. It's very interesting looking at you putting in your thoughts. But definitely that please feel free to raise hands. Helen, can you launch the second poll? So the second poll, we're asking you what you think. These are just some subset of the challenges. So, and then again, technical and non-technical challenges. We want to hear your thoughts on that. Take your time to express your thoughts on that. But at the same time, we really want to hear from you, your thoughts on use cases and challenges for cybersecurity that could benefit from big data science or data science tools. You've heard a lot about the data type of related challenges. What else? What other challenges do you see? I'll put a comment here that I think that there's indeed a lot of data challenges. Personally, I think that it's going to be very difficult, like in some other data science domains. I don't think there will be a lot of ground truth labels, label data in this domain. And I think that there's also a very fast evolving nature of adversary behaviors, as well as our networks, our systems. There will be the vulnerabilities will change very quickly. So methodologies, effective methodology, I think need to be account for those facts. What are your thoughts? Do you agree with me? Not agree with me? I'm so used to people not agreeing with me. Florence is one of those, and I really enjoyed that so much, Florence. Thoughts? I will bring up a few questions being posted online. One of the is talking about which database models are the most successful to tackle emerging cybersecurity threats. Time series database, graph-based database, NoSQL, no document kind of thing. What are your thoughts? What kind of database would be great for cybersecurity problems? Jelena, do you have any thoughts on that? You mentioned about a few data.
I guess that depends on the problem you're addressing. In our work, we worked a lot with time series data, but it really, cybersecurity is broad, and it depends if you're working with passwords or block lists or something. Like it will be a completely different kind of problem that you're addressing.
Let me give a different answer to that question. And I think Jelena is absolutely right. It depends on the problem, right? So because we try to integrate data from multiple sources, we have developed and still developing a thing called polystore, which means there are there's a graph database underneath it, there is a time series database underneath it, and these are all standard systems. But what we do is we take an analysis problem and we make them look at all the different kinds of data and exchange information. So we have figured out that this is possibly one of the more comprehensive ways of doing multiple kinds of analysis on different parts of the same data.
Thank you. I also see quite a few students online as well. Some of them I know. I don't want to call your name. I know that I know you. But students, if you are working in this area, if you have any thoughts or questions, here are a lot of great professors here or practitioners here for you to ask your questions. This is your opportunity to gain those answers of your work. Some other question we're talking about CIDA. So CIDA does have this network telescope collecting a lot of data. I know Sagar also has ample data from the dark web and vulnerability elements. I have actually shared with several links to a variety of data sets that people have posted online from US, from Canada, from European, and many other places. So there are data. The question is, are those data usable? And are they data solving the problem that we are tackling? What are your thoughts? And we know the audience also have a lot of practitioners. What are your thoughts about, are those data realistic or not? So, God, do you have any thoughts?
I do. So one thing, just to kind of circle back on if I can just summarize some of the data characteristic issues that we've heard so far on the panel, and then I'll delve into some of my thoughts in terms of data challenges and so on. So I think if I can just summarize what the panel has said so far in terms of as it pertains to data, I can really put it into 3 or 4 words. So I think it would be data acquisition, data representation, and then data processing. So let me talk about both of them. So data acquisition is how do we acquire realistic data that is actually going to help us out with some of our analytics or some of the data science issues that we're seeing. Data representation is how do we represent the data? Do we represent it as a time series kind of issue? Do we represent it as a graph? Do we represent it as a sequence, and so on and so forth? And then the last bit is that how do we make sure that the data is labeled and it's in a way that we can actually use it for some sort of analysis. So I think those are some of the themes that we're starting to see from the emerge from the panel. They're kind of synthesizing some of the comments that we've got so far. Now, as it pertains to kind of my perspective on this, I'll just give an example of the types of data that I collect and the way that I structure and format them, and then maybe we can get some better sense from the other panelists and from the audience as well in terms of different use cases. So for me personally, a lot of the data that I gather is actually not secondary data sources in the sense of downloading a data set off of the web, such as CIDA or existing data sets that folks may use. Those, I'm not saying that there's anything wrong with those data sets. Those are very good for showing the maybe the academic rigor of certain approaches, making sure that your models are outperforming the state of the art and so on and so forth. But really what I focus in on is collecting data from the source directly, in terms of collecting data from dark web sites or social media sites and so on, exactly what the hacking behavior is actually like out in the wild, so to speak. And that brings into account several different challenges, because that data is quote unquote live and it's adversarial, and there might be some other considerations in terms of data acquisition and management that may not be obvious right off the bat. And I'll give one example. When I was a PhD student at the University of Arizona, I was collecting a lot of hacker forum data and collecting a lot of the data. Well, at one point, my virtual machine that was collecting the data had 600 viruses on there because of the people that were trying to attack me back, right? So these are some of the unique challenges within the context of data science for cybersecurity that's unique to a particular type of data set within cybersecurity. And similarly, you may see some of those types of adversarial behaviors as well. Now, in terms of the database structures that I lean on, I primarily use MySQL and MongoDB, and I found that to be sufficient for the type of work that I'm doing. But I'd love to also get some thoughts from the other panelists, like Jelena, in terms of some of the data sets and structures that you use that you found to be useful in your work.
Right. The data sets that I use, I used a lot of data sets from CADA. They are great. I'm very grateful to CADA for this, long time collection and sharing of data sets. And I used some data sets from Impact cybertrust.org, which was the DHS sponsored project to share data. They organized it so that the concerns that were arising about privacy of data sharing were kind of ironed out through legal agreements, through memorandum of understanding. And so anyone could join it. The join process was a little longer than for other sites because you had to be vouched for by your organization, but then once you join, you can request different data sets that you couldn't otherwise, and you would get approval. And then lately, we've gotten some access to real data sets from the network providers, and those are sadly private so far, but we're working with them to be able to release them to wider research audience.
Thank you. So I hear a lot of great conversation here. There's also another parallel conversation on the chat from Caroline, as well as that I think from Osqua, talking about this point on real world problems, real world data, real world feedback, real world uses with research, right? So research advances in terms of connecting between the research and the practice. And actually the poll results, I think that most of you can see right now, the highest percentage of you talking about the mismatch of incentive goals between the research versus industry application focus. That's actually one of the top outcome of your poll. So that is one of the biggest challenge, followed by some others. And the second one is limited collaboration between cybersecurity and data science experts, right? So again, it's the collaboration. So I want to bring that as a problem here. I think Kathy might have some thoughts there in terms of practical problems and research advances.
Yes, there are challenges there. So in the large facilities, representatives that are interested in taking advantage of some of the new data analysis techniques, it's just difficult for them to have the resources and the personnel to have time to get familiarity with these concepts and how to deploy the tools in their environments. They are trying to do the best they can day to day in dealing with the cybersecurity challenges, but adding these new skills and just kind of picking up with the science that's sort of in its kind of early phase here is a challenge. So they're interested in ways to ease that integration very much.
Thank you. And now you had your hands up, please.
Yeah, so I think this sort of ties together with both the points of sort of the lack of integration necessarily between academic and sort of real world practitioners, and as well as what sounds like a very disjointed sets of data, and other problems around that. And because this is the cyber infrastructure working group, I was just going to put the bug in people's ears around that. About we talk about which database do you want to use, which this, that, and the other, and there was a brief discussion about Polystore, which was the beginning of a cyber infrastructure for these problems. And so while we're thinking through all this, I wanted to just ask people, what would you want from an infrastructure if we could suddenly, and I don't want to use a magic wand to make all the NDAs go away, because that's never going to happen, but if we were to reduce some of the hurdles of entry, would really benefit this two-way discussion of both research on data and publishing algorithms, so that people can then validate those coming in from outside, going into then what would sort of be discussed as a fair type data system. If my rambling makes sense to people, what pieces are you needing to make it so that you can get to enough data and other pieces of data, as well as allow people to test algorithms and work with things to broaden the adoption?
Thank you, Niall. I think that's very interesting. So I'll provide a little bit of my perspective answering the question you just raised. So I think for the researchers, actually a lot of times we want data, but we really don't care about the legal people, what legal people might have cared about the specific IP address, specific URL, specific payload data. Some of those things that we don't necessarily care as much. Of course, that there are cases we do. There are a lot of cases we don't. So oftentimes the blanket statement about, oh, we need this NDA, I think Oscar mentioned that, we need that kind of contract, we need to anonymize in some way, there's no way to anonymize. I think the blanket statement makes it so hard. In my opinion, that there are actually a lot of ways to work around. So in my opinion, if we as a community can list that, I can provide mine, that here are the data and fields that I really need. The rest, I don't need them. And actually, we have experience been successful on that. And the CISOs and the legal people say, look at, can we realistically release those fields, but not the other fields, right? Don't think about blanket statement. I think that can alleviate a lot of concerns that connecting the industry, the actual practical operations with the researchers. Someone was Renata? Yeah, please.
Yeah. Hi, Jay. How are you? So hi, everyone. I'm Renata Rawlings-Goss, the Executive Director of the South Big Data Hub. So Florence's counterpart, I think we're all on here. One thing I had a question for the subject matter experts in cybersecurity is particularly we have a working relationship, a fellowship program with the Department of Homeland Security around looking at threat detection and recruiting subject matter experts. So, I mean, we have a fellowship program for faculty and for students in cybersecurity, but really looking at this forward-looking threat detection and how, what types of techniques really work well for predicting cyber attack, or looking at in the way of more forward-looking analytics. So, just your thoughts on that, and also, I can also put in the chat if you're interested, or if this is something that is in your area. Thinking about, we're going to open up a program for actual subject matter experts in this area, which is already out. So those two things, so that question, and then I'll also put in, if you're interested, you can look at the link and just let me know, and we can email more.
Renata, I'm so glad you mentioned about prediction. That's my area, and really, really excited to hear that, but I want to hear other thoughts first. Feel free to unmute yourself and talk about that area. Renata, you can also feel free to, you already shared the link, thank you.
Yeah, so I can chime in maybe. Oh, sorry.
Yeah, no, go ahead.
Okay, I can just chime in briefly. We've been working on detection of DDoS attacks, and we've been using LSTM, specifically multi-timescale LSTM, so looking at different timescales and trying to predict and using different kinds of signals in traffic. as well as regularity of attack patterns. And that works very well on the data we have, but we have abundant data in that area from a big network provider. And this is not going to be the case if you have smaller amounts of data or if you're trying to predict something that is not very regular.
Thank you. Caroline, please.
So I'll just give a practitioner's viewpoint from this. So I'm not an academic. I'm a practitioner. I work for a big data company and I help customers with big data cyber solutions. So what I see out there in the industry is probably so predicting might be difficult, but looking at the potential vulnerabilities and the likelihood that they'll be exploited, and looking at kind of what are your paths to your most dangerous attacks and finding them and then patching them or remediating them might be the best way to do that, because there's so many in the in the real world, there's just so many things that can happen. But there's kind of there's a short list of attacks that are common, and there's a good set of vulnerabilities and kind of weak points within the system, and finding those, the biggest ones, the most dangerous ones, are probably the best practical standpoint. But I think predicting is obviously, that's kind of the visionary that's the visionary problem to solve.
Caroline, thank you for the comment. Indeed, that I think prioritizing the indicator of compromise, be able to predict what might be the most impactful attack is definitely a very interesting part of it. In my personal experience, one of the things that the analyst, SOC analyst, is looking for is how do we help them to prioritize the overwhelming amount of data, right? So I absolutely agree with you. I think that the industry also need to start thinking about that. How do we stop looking at all the event logs, all the network flows, all the intrusion alerts, right? Because there's so much of them, and start thinking about, can we look at the summary of ongoing attacks, right? So few of them, right? Instead of hundreds of thousands, looking at tens of them only, or even within 10, prioritize them. So there are some works out there in industry and academia in those elements that could help in those. I can chat with you offline more on that as well. I think that we are moving already start towards not just challenges and use cases, but also solutions and best practices. Certainly most of the audience are in the cybersecurity area, but I also hope to hear from data scientists or people who work in other science area. And given what you have heard so far, do you have any thoughts about, hey, that problem, we have seen it before, right? Getting the users to use it, that we have seen it before. Getting people to share data, oh, we have done that before. If you have any thoughts on sharing your best practices, whether or not it is for cybersecurity, feel free to share. We'd love to hear from you as well. Sagar, I know that you have been working hard to summarizing some of the things. Do you want to share a little bit of your thoughts, your observations so far?
I think just to build on what I mentioned a little bit earlier, I think the key themes that I'm seeing that are coming up in the discussions here, great discussions, is related to kind of the data access, the data representation, the data labeling, the data management aspects as well. But I think just to add on to that, in terms of what else we've seen so far come up, is that really that how do we bridge the practitioner academic landscapes and that perspective as well, in terms of being able to take a look at what practitioners and academics are doing, working hand in hand to address some of these issues simultaneously. I saw in the chat that there were a few other concerns that I would lump into a similar theme as well, in terms of issues with data set access as it pertains to MOUs, NDAs, and so on and so forth. That's a major point of concern for some folks as well. That may be a little bit different than other data science contexts. I'd love to get some thoughts about that. That would need some navigation as well, in terms of how do we actually mitigate some of the concerns that folks may have to actually be able to publish some of the findings from the data sets that are being used from a commercial point of view and so on.
Thank you, Sagar. That's great. I continue to track. There are a lot of chat going on. So it's like so this is a very interesting experience, right? Like we have 3 channels. One radio channel that's this voice. The other channel is on the chat, and the third channel is on Google Doc at the same time. It's very interesting how we chat that. I've seen Sven just talk about some conversation with Jelena. Sven, you want to talk a little bit about your questions, or Jelena, you want to comment on those?
I can comment if you want. Can you hear me?
Yes.
So I guess Yael and I were just chatting about labels of the data, and the point was making was that you could assign different labels to the data and different evaluations. But my point was the fact that it needs to be dynamic, right? As even if we have a certain set of some certain data set that at one point gives us one insight, you run it through a different algorithm, or you have some ground truth later that tells you that another label needs to be assigned. So there's a need to have this dynamic labeling. So that was really I think the summary of the conversation. And Jelena, feel free to jump in if I didn't represent your point of view correctly.
I agree.
Is there an example of where dynamic labels need to be assigned?
So what I was talking about in the chat, there was a question about the probabilistic labels that I mentioned, and I said we have many algorithms for anomaly detection or for detection of various kinds of attacks that we want to look for in data. But these algorithms can be more or less effective. So instead of using them to label with the absolute ground truth, we can label by saying algorithm XYZ said this is abnormal. And then we can have multiple labels for the same record, just like VirusTotal has many antivirus engines. And then when you do research on malware, you will say something like, well, I selected malware from VirusTotal that had 80% of tools label it as malware, and I am going to work with that data set. So conversely, we could then, when we evaluate, let's say, scanning detection, phishing detection, whatever detection algorithm we are evaluating for different anomalies on data sets, we could say this was effective on, 95% effective on data that was labeled anomalous by 80% of the labels. So that would give us, better way to progress in case of uncertainty. And then Sven was saying that the labels are dynamic because we always learn more about the data set. That's absolutely true. And more algorithms emerge. So you can see this set of labels as an evolving set over time.
Great, thank you. So in a few minutes, I would like to move into the next topic, the topic on the education training engagement a little bit. Before we close that, I see a few other questions that not necessarily being discussed yet. So one of the challenges by Asqua talking about is, I think about students, from the students' perspective. Asqua, do you want to talk a little bit about from student perspective, your thoughts?
Yes, hi. So I did raise a couple of points which I don't really remember, and but basically the point was that as a PhD student, we usually have a fixed term contract, and well, figuring out these NDAs and setting up these collaborations with the companies can take a long time. There's a lot of red tape around it, and I think that's a really big issue because there's a lot of research that is done by the graduate students, but because there's a high turnover then like these are some of the issues that well, the research community needs to work on together so that we can support the graduate students who want to work on these challenges. Otherwise, there's a lot of work that's going into these problems, but then there's no good solution coming out of it because these are problems that, well, in the end, it's just okay, we have some solutions, but the solutions are on data that's not representative and so on, and then the cycle repeats itself. And another point that I had was about these toy problems. So in AI particularly, there are toy problems for at least emerging research topics, and that's how sort of a research field builds itself. And then once it's mature enough, then we start going more into the complex sort of edge cases. And that is something that I think we are sorely lacking in security. I have rarely seen toy problems being appreciated, at least in academia and also in industry, because of course they are really dealing with the real world problems. But then because there's this problem with access to data, and then you don't have data, but you have techniques, we could kind of work on toy problems, but then it's not really appreciated. So it's kind of like, I don't really know what solution there is to this problem. Yeah, sorry for rambling on.
No, thank you, Asqua, for raising a voice of from a student perspective. Absolutely. Any panelists or any people on the call have any comments, or industry or operational people have thoughts?
In many fields, there is a community effort to create data sets for specific research, a specific kind of study or wide kind of study. Is there a chance that this field will start creating shareable data sets that students can work on, student researchers can work on? I think a lot of people would possibly love to contribute if there is such an effort.
So I think that's a very good point. And I know that, for example, for the malware case, there are some open data sets that some labs, so for example, there's a lab in Prague that works on malware, and then they release network traffic. But the issue that I've seen is that when we try to publish with that data set, the reviewers always come back saying, well, the data is too old, it's not representative anymore. And that is, I think, a big problem in, I guess, the mindset, because by the time you're ready to publish, the data will already be outdated. That's just the nature of the landscape.
Right, Asqua, I agree with you. I understand this concern. I actually share a few links, data sets out there that's open, that you don't need to sign in and things like that. So the reality, the problem you mentioned, there are two sides of stories, right? So one is that what kind of data sets are out there available? And second is the reviewer's mindset, right? So I do agree. I think that using realistic, up-to-date data is excellent. And this particular problem for cybersecurity is a little bit more exaggerated, not exaggerated, it's more amplified because the cybersecurity problems are evolving faster. So our faces, right, face recognition, think about that. Our face doesn't evolve every week, right? But our network, our devices change every week. Attackers' behavior change every day, right? So that makes it a lot harder. So I do think that the community needs some effort to think about a pipeline in creating data set, and not necessarily label. I think labeling is going to take a long time and be far behind. So how do we create unlabeled or semi-labeled data set, allowing us to work on a variety of different problems, whether it's website fingerprinting, whether it's the log analysis, whether it's malware analysis, whether it is whatever, right? So there are different kinds of data. There was a question about anonymization. I think that John mentioned, Sagar commented on. Like I said earlier, I believe actually if we don't use a blanket to say, no, this is not possible, then we can look at different types of data set and how to anonymize would be great. About 10 years ago, there was a study by a group of people, including a professor in Indiana University, Sagar, I forgot her name, and talk about the different kind of cybersecurity data that's needed. I think that some of the documents, some of that report was still valid today. It's still valid today, but we think we can renew that and really work on the industry and academia collaboration. Caroline, definitely want to follow up with you on that. I think that we want to move on to the next topic. Very quickly, already went through 1 hour. So I want to touch upon the next topic a little bit. This is just the beginning of our community discussion, so we'll have a chance to come back to this. The topic we haven't talked a lot about is how do we engage, how do we educate, how do we train, whether students practitioners, or me as a professor, right? So I want to be trained, I want to be educated as well. In fact, that over the past 2 years, I've been educated significantly by practitioners. And thank you all of those people in OmniSoc and CACR and some other places I've heard from you. You really opened up my eyes. So I think this is a bi-direction or actually trilateral educational opportunities for researchers, practitioners, students, and so on and so forth. I want to really open up the forum to talk about ideas, realistic ideas, how we can effectively engage, educate, train students, practitioners, researchers, professors, right? All of us. Thoughts? Kathy, do you have any thoughts about what might be the things that practitioner might need to support large facilities and things like that? What do you think?
On the practitioner side, often like case studies or examples that of implementations that have worked at other sites. Use cases are very helpful, kind of examples of implementation to get people thinking about the ideas and how they might use it.
So specific use cases and scenarios.
Yes, use case scenarios, best practices that kind of go along with that. Those are very helpful in implementations, definitely.
Thank you. Thoughts?
Let me ask a quick question. In many areas of machine learning and data science, you will see Kaggle challenges. So you put together a data set and you say, here is a problem we are trying to solve, now go for it. Different groups try different things and everything is open, right? You can see other people's solution when they are ready to submit it. And I'm wondering whether it's feasible, if we have, again, some agreed upon data sets, could we, one way to educate people is to put them in the middle of a problem and see how different people solve it. Do you think such an effort is taken or can be taken?
So one of the famous KDD 99 challenge, right? That was one of the old data set that Asqua mentioned. That was one of the efforts for that. But I think that if we have some ongoing effort, right, sustainable ongoing effort, and maybe this is something the working group of big data hubs can help, right? Continuous curation, collecting even small, the real world data for the students, for the practitioners, for the researchers to continue to tackle, discovering new things. And let's not talking about label data. I mean, we could, but I think they'll be very difficult. Asqua, you raise your hand, please.
Yeah, I just wanted to add regarding this competition. So I've seen some conferences that have workshops that actually do organize these kind of competitions. They have a data set, they have a very specific kind of problem. So my group actually took part in an adversarial malware detection challenge where the goal was, so the framework was already there. It was a deep learning based framework and they had some binary PE files. And the challenge was for attackers to craft adversarial malware examples and for defenders to, without basically looking at the attacker files, design a malware classifier that could detect adversarial malware examples. So basically, this was an environment which kind of simulated the real world environment where there are attackers that are crafting malware samples without knowing what the defenders are doing and vice versa. And that actually worked really well. And in the competition results, then the organizers ran the submitted attack files against the defender files. And then there was this competition and then a big table that showed the accuracy values and so on. And the winners were announced. So I think it's a good opportunity that really promotes innovative thinking. And especially in security, this kind of simulates what happens in the real world. So I think it's a good idea and more people should do it.
So I really like a lot of this discussion. I think that one of the things we will do at the end is what are the next steps. So we can potentially list a repo of data kind of challenges, right? Cybersecurity challenges that for students, even the past ones, they might be posting some solutions and use cases, scenarios that would be great. We can maintain some kind of repo for that purpose. I'm also wondering, have any of you heard about any of these challenges where we invite both practitioners and researchers, right? I'm not saying competing against each other. That would be fun. So because there are some very expertise, like human expertise, I think AI, ML, data science are not there yet. At the same time, there might be AI, ML, data science approaches that's very interesting. Think about having practitioners competing against researchers. I'm not sure whether those things exist or not. And if you know, please voice up.
Well, in some of the capstone projects we do for data science students, we do involve the industry. So there is an advisor, for example, the first problem I mentioned, there is an advisor from Cisco. And obviously Cisco is like in the middle of many problems, they see a lot of problems. And their advice and the way they sort of help students understand the problem better is invaluable.
Absolutely.
But these are longer problems. So it's a 2-quarter capstone. So there is a lot of time for interaction.
Other thoughts about engagement, training, education?
So I agree with everyone. We need competitions and public data sets. We have a proposal to do a hackathon at SIGCOM. I don't know if it's going to be approved, but if it gets approved, then that would be a good opportunity because we will be bringing one of such data set and challenging people to find all the attacks in data set. In the past, that was done mostly in these big government funded efforts where you have like a synthetic but realistic data set with attacks and the legitimate traffic, and it's all labeled because it's synthetic, right?
So on that note, and one of the things that having competition and challenges, I think one of the things to make it really usable and sustainable is having something recorded, either the actual network data, right, as well as that humans take on the data, right? For example, in RIT hosts the CPTC, actually it's international now, collegiate penetration testing competition. I've been working with organizers to collect the data, traffic alerts along with the competition. And I think that Ansho Reggae, I don't think that she's here today. I had a project with her a couple of years ago, and she's collecting from a human perspective, what do the team members in competition, what do they think? What's their strategy, right? Document that. At the same time, we collect the raw traffic data. This allows a very unique kind of data set, and every year we can do this. Of course, the projects will not run forever. But if we have some sustainable process like this, right? So whether it's CCDC, CPTC, or some other challenges that regularly happen, and then the organizers allow us to collect data, both from the human side and the network side, right? And every year we have renewed data, right? Renewed data and renewed data. This way, the community will have new data every year to work with, and every year to be able to have both the raw data on the traffic side as well as human labeled data. Not necessarily labeled, but human commented data. So in the group, in the community, those who are involved right now, I see there are a lot of people that some of them I recognize the names from practitioners and thoughts. Earlier we talked about some other type of challenges, not just network traffic, but also disinformation and other types of maybe phishing, website fingerprinting, other things. What other challenges do you see as practitioners and researchers? And how do you think that engagement and education help in those problems? So, I see from Maturia, I'm not sure I pronounced your name correctly, Johnson. You talk about something, a data-thon started in MATLAB. Do you have anything you want to share, thoughts you want to share? I don't know how to pronounce your name, apologize.
That's okay. It's pronounced Manchuria. It's like Manchuria, but you drop the N for Manchuria.
Oh, hi.
Hi, this is very good. I'm a instructor at the Houston Community College in Texas, in Houston, Texas. And so this year was the first time that we participated in the data-thon. And my background is database administration, SQL Server, DBA. And so I just threw my students out in the deep end and we worked through MATLAB. And so it was a great experience to help us to participate. And so now I'm not very, I know C, but I'm not very good at Python. So we're recreating the project in Python. And now that the students understand the problem now and they understand the solution, now they can take it to Python, they can take it to Oracle. And what's so cool about that is that they know the problem now, and now they're just seeking out what tools to use. So that's my contribution.
Great, thank you. If you have any links or anything that you can share with us, feel free to put in the Google Doc or on the chat. We'll be able to capture that into our shared document with the community. Thank you.
Thank you.
I think that we are at 4:12. I do want to be respectful of everyone's time. We have the last topic. Really, I think it's very important. We have heard a lot of very good conversations so far from a lot of people on ideas, challenges, solutions, best practices, and things that we do. One thing that we want to do is next step for this community. So we do not expect this workshop will solve all the problems that we have had in the past 20, 30 years, right? So it is, when we think about next step, what are the tangible, real things that we can do next to continue our conversation, continue to build something that can be helpful, useful. So I'm going to ask Helen to launch the final poll about the next steps. At the same time, there are in the Google Doc, there are other bullets because the poll is only limited number of options. And definitely you can share your thoughts. But more importantly is that if you have any specific ideas, please put down some in the bullet points in the shared document. Thank you. I think that Florence, you just share again on the Google Doc. Thank you very much, Florence. So put down your ideas and thoughts that you think that can be helpful. And then we'll compile it. Don't worry about the organization as much. Just put down your thoughts, your ideas. If you do want to help explicitly, feel free to put down your name, your affiliation, and contact information. We'll be happy to reach out to you to see how we can involve you directly. Yeah. So as the polls are coming in, we'll wait a little bit. We have about 30-something% voted at the moment, but we'll wait for a few more minutes. Meanwhile, I do want to hear a little bit more about your thoughts that what we can do. I mean, we can actually really open up the conversation. What do you think that we can do specific? Anything you have heard today that you think will be the best thing to do immediately, we should do immediately, whether it's for students, from practitioners, from any researchers, any thoughts, what we can do immediately. Can you, I'll be happy to, please just raise your hand or just unmute yourself, start talking. Love to hear your thoughts.
Okay, everybody is silent, so I'm gonna unmute myself. So I'm a practitioner. I love to actually do things. So I want to make some connections and I want to come up with a way that we can collaborate to get some of this academic work. I see so much great academic work in the area of cybersecurity, and I feel like we have a lot of the elements that we need in order to make a big impact. But right now it's just, we're not working together. So, how can we get a start on this? That's what I want to solve.
Caroline,
I have a whole platform, right? I've got Cloudera data platform. I've got ways to share data. I've got ways to catalog data. I've got big data. I've got machine learning tools. I've got Python. I've got Scala. I get like all the tools that you guys need. But I need the brains, they need the brains of the operation. And my customers are super interested in AI. And a lot of people are talking about AI in cybersecurity, but it's just not, it's really unattainable for them with the current level of, data science capabilities that they have, so.
Caroline, I'm very glad to hear that. We definitely want to involve you. Sorry to interrupt someone.
Jay, this is Amarnath. Okay, so one of the things the academic people would want from the industry is we would like to talk to them and get a sense of the kinds of data they have. And we want to see if we can create a synthetic data set with the same characteristics that they see. Part of the disconnect that we heard about between academia and practices is, very often academia will never get access to the kind of data that the industry has, clearly. That is understandable, but is it possible to look at the characterizations of those data and to create synthetic data sets? Can that be a kind of collaboration that can happen between the two groups?
Great, thank you. That's excellent thoughts. I think that I do want to, Amarnath, this is great timing. I want to look back to the panelists. Any of your closing thoughts and next step, anything that you want to discuss a little bit while I'm looking at the poll results. Jelena?
So I think we had a lot of great discussion. There's a question in the chat I want to elevate from a high school student looking for suggestions to, I think, about materials. He's just getting into cybersecurity and data science. So if people want to give some suggestions. Yeah, I thought it was great discussion. It sounds like it's a just start of a long and wonderful discussion for us all to have as a community. How do we improve the cybersecurity as big data science?
Thank you, Jelena. Sorry, I missed that one. So very good to capture the high school. This is great. We have high school students here. Hey, Florence. Danny, I don't want to put you on the spot, but if you do want to speak up, please feel free to unmute yourself anytime. Meanwhile, we'll go to Kathy and Sagar as well. But I want to share with you a little bit about the poll result. You probably can see yourself now. I think that we have a lot overwhelming, more than half, 60-something% want to have shared repository, things like that. Excellent. Some kind of catalog, yeah, some kind of expertise and interest catalog for people, right, to find collaborators. I think that's great. So we'll work on this. We'll take this into input and see what we can do as a community. And if you want to volunteer to help certain things, I think that will be excellent as well. Florence, you just made a comment about Caroline and everyone to the May 7th discussion. I think now that was the plan, right?
Yeah, I think we could maybe proactively send them the invitation after this, perhaps.
Yeah, no, I've actually drew up a real-time slide with the info so that everybody can spam Jeremy and get invitations.
Good job. The other idea,
I'm gonna put that up.
That sounds great. And Jay, the other idea we've talked about a little bit is if part of this group would like to work together to submit either to PERC or SC, either a panel or a BOF. I'm wondering how we can get other people in the boat with us if we think that's valuable, or maybe we're not ready, but that's another opportunity.
Right. So I think that definitely there are a lot of venues we can definitely try, like you said, PERC and other things. I think Sagar also has something that he wants to share that coming up as well. So definitely, Florence, I absolutely agree with you. I think that if you have, in the audience, you have any thoughts on specific venues you think it will be best for this community to continue to have the conversation, please feel free to put them down. I think I already see PERC in the Google Doc as well. And definitely that will be great. And I think Jelena mentioned about DEF CON. Is that what you, I forgot what you exactly you
No, I'm sorry. I talked about SIGCOMM hackathon.
Yes,
but there is also, yes, there is, I'm part of hot SOS Science of Cybersecurity that is happening, I think, tomorrow until Thursday, and there's also going to be a session there about big data and cybersecurity.
Great, good, excellent. Sagar, you want to comment a little bit, and Kathy?
Yes, I really think a part of the challenge is bridging the gap between the data scientists and the cyber infrastructure, cybersecurity professionals who are trying to look at how they can use the new technology developed and deployment. It would be interesting if somehow we were able to tie together some of the groups in the large facilities with a research problem and maybe be able to scope a problem and you know, have some collaboration there with real world data. And I think that would be pretty exciting.
Great, excellent. Sagar?
Yeah, so I just put in the chat a link to the editorial that I was talking to a little bit earlier about a lot of the issues that we talked about today in terms of gaps between practitioners and academics, the different types of data sources, some of the key issues related to data access, representation, and so on and so forth in there. But I think, Jay, if you don't mind, I can go ahead and share some of those other opportunities that we had talked about as well. I think Christine had suggested for us to talk a little bit also about you know, some of the funding opportunities that are related to this space as well. And this is also in the editorial as well. But I think that there are funding opportunities related to doing data science for cybersecurity, that multiple programs of the National Science Foundation. I understand that there's more than, you know, just the US that's represented here, but these programs have funded topics related to data science for cybersecurity or have done things. And I just want to kind of summarize some of the high points of this, and in the editorial there's a more comprehensive summary of them, but there's all the way from the early career stage to infrastructure, to developing infrastructure around this. And so, for example, SICE Community Research Infrastructure has supported various cybersecurity related infrastructures out there. Core research related topics such as secure and trustworthy cyberspace and cybersecurity innovation for cyber infrastructure, to transition to practice and education as well. So there are a few opportunities that out there that are actively funding topics related to what we had talked about today that would also be potential suitable outlets as well that could be searched for as well. And then just to put a little bit of a plug in, we have a couple of upcoming events related to this as well, more from the academic side, but we have practitioners on the program committees related to this as well. So at KDD and IEEE ICDM, we see our leader here as one of the co-founders of the workshop. So we have, you know, Jay and Dr. Chen as part of the KDD workshop. And then also we have the ICDM workshop that's related to more academic related work. But again, we have practitioners in that space as well. So a little bit of a plug in for upcoming activities in those realms too.